Happy President's Day, Geometry. So I'm gone today, obviously. So you're going to be watching this lesson video. I'm going to quickly go over the first page of your notes because this is a review, but just to make sure you're doing it right. Either pause the video and check out my work, or just check your answer with mine. Here we go. Okay, so obviously Pythagorean theorem is right here. C squared equals a squared plus b squared. We've used that a lot. Let's just make sure we remember that your hypotenuse is always across from the right angle, and it's the biggest side. So x in this case. And you should have gotten x equals 10. Then on this one, we mix it up. And this time we're given the hypotenuse because 6 is across from the right angle, and we're just looking for a side. And we find that x equals 2 square roots of 5, which brings me on to it. It says simplify radicals when necessary. And if you forgot how to do that, that's okay, but that's kind of the big idea on this lesson, so you need to know how to do it. So if you look right here, we got the square root of 20. And you can simplify the square root of 20. You have to think what perfect squares go into 20. And remember, perfect squares are number times themselves. So like 4 is 2 times 2. And then we go to 3 times 3 is 9. Then 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 49, 64, and so on. These are perfect squares. But we were looking for one of these that went in perfectly or evenly into 20. And you notice that 4 times 5 would give me 20. And 4 is perfect squares. When we simplify, we get 2 square roots of 5. Similarly, over here on this last example, we get the square root of 75. Again, we can simplify. And I gotta think which one of these numbers over here can go evenly into 75. And quarters. 25 cents was in 75 cents. How many times? 3 times. So square root of 25 is 5, and I can't reduce the square root of 3, so it stays. So 5 square roots of 3. Okay, scrolling down here. The converse of the Pythagorean theorem. C squared equals a squared plus b squared, then obviously it's a right triangle. If c squared is greater than a squared plus b squared, then it's obtuse. And then if c squared is less than a squared plus b squared, then the triangle is acute. So again, these examples down here, you've done before. All you had to make sure was you put your c, which is the largest number out of 3, so 6 was your c value. Crunch the numbers and see what you got. This one you ended up with 36 is less than 41, so it's acute. 0.36 is greater than 0.25, so it's obtuse. And 2500 equals 2500, so the triangle is right. Again, I know I went through that quick. Pause the video, check over my work if you need to. If not, we are moving on to 8.2, special right triangles. So at first you're going to hate these triangles, but then you will soon love them once you get the hang of them, but it will take a little while. These two triangles, we're going to learn shortcuts how to find their side lengths quickly and efficiently instead of having to do the Pythagorean theorem over and over and over and over. So first off, what do we know about a 45, 45, 90? Well, it is isosceles, right? Because I have 2 angles the same, so that means I have 2 legs the same. So here's my right angle. Here are my 2 congruent legs. Now let's see if we can figure out the shortcut here. So we're going to call our congruent legs S and S because obviously they're the same measure, so they're going to get the same variable. And let's call our hypotenuse X. Now we're just going to perform the Pythagorean theorem. So S squared plus S squared equals X squared. That's exactly what we were just doing on the previous page. Now let's combine like terms. How many s's do I have? I have 2s squareds equals x squared. So now I gotta think, how do I undo something squared for this x? Well, we take the square root. So now I have the square root of 2 times the square root of s squared Well, the square root of s squared is just s. So now I am left with s times the square root of 2 equals x. Now this is your friend. We have just proved the shortcut on how to find side measures of a 45-45 right triangle. So the shortcut is your hypotenuse. Please underline this, circle it, star it, whatever you want to do. The hypotenuse of a 45-45-90 triangle, guys, is your leg length. So let's say it's s times the square root of 2 always. So let's say my leg length is 4, then my hypotenuse is 4 square roots of 2. It's literally that easy. So please bubble this, circle it, just know that your hypotenuse is the square root of 2 times the length of your leg. Okay? Let's try a few examples here. Okay, I'll leave that up there so you can see it. Okay. So here we have a 45-45-90 triangle, and we're going to find all the missing sides. So again, here are my two congruent sides. So if this is 8, then this side is 8. And what did we just learn? The hypotenuse is 2 times your leg length. 2 square roots times your leg length. So I'm going to have 8 square roots of 2. Boom. Done. Go on to the middle. Again, here's a leg and here's a leg. So if this guy is 9, this side is 9. Now how do you find the hypotenuse? You take your leg, 9, times the square root of 2. Square root of 2. Okay? Now this one, there should be little tick marks on there. It's marked wrong, but we have a 45-45-90 triangle. Again, with a leg length of 17 and 17. Now how do we find the hypotenuse? Take 17 times the square root of 2. So those are pretty self-explanatory. I hope you understand those ones. They get a little more interesting once you turn the page. So let's turn the page. So now this time we are given our hypotenuse. This time we see our hypotenuse is 5 square roots of 2. So if you don't see the shortcut right away, that's fine. You can always fall back on the formula. Remember, our hypotenuse equals our leg times the square root of 2. So now let's plug in what we know. We know our hypotenuse is 5 square roots of 2. Again, we're looking for our leg lengths, right? So we don't know what these guys are. So how am I going to get my leg by itself? Well, we got to divide by the square root of 2. Divide by the square root of 2. It's pretty nice. It cancels. It cancels. So we find our leg to be 5. So we just found our legs of our isosceles triangle to be 5. Moving on to example 5. This time we're given our leg to be 2 square roots of 2. So my leg over here is 2 square roots of 2. Now how do we find our hypotenuse? We take the leg, so 2 square roots of 2 times the square root of 2. Now we're just simplifying. 2 stays by itself. Now what's the square root of 2 times the square root of 2? That's the square root of 4. Can we simplify the square root of 4? Surely. Which is, the square root of 4 is 2. Now, 2 times 2 is 4. Okay. Next question, what is the length of the hypotenuse of a 45-45-90 triangle with leg length of 5 square roots of 3? Draw a picture if you're having a hard time visualizing this. There's my 45-45-90. Remember what they give you? It says, what's the length of hypotenuse? We're looking for this if we have a leg length of 5 square root of 3. So again, punch it into our formula. We take our leg times the square root of 2. So what's my leg? 5 square roots of 3 times the square root of 2. So I guess remember there's an imaginary 1 right there, so that's why 5 gets to be 5. So I'm taking 5 times 1, which is just 5. Now I'm taking my radicals times each other. 3 times 2 is the square root of 6. Can I simplify the square root of 6? No. So we just found our hypotenuse to be 5 square roots of 3. I lied, 5 square roots of 6. Now this is, if there's going to be any kind of a problem today that kind of messes you up, it's when you're going to have to work backwards from the hypotenuse. So that's this kind of problem right here. So again, we're just going to fall back onto our formula. Remember, our hypotenuse equals our leg, I'm just going to call S to simplify, times the square root of 2. So I hope we can all agree that right now we know our hypotenuse is 6, and we are looking for our legs. So I'm going to plug in 6 for hypotenuse, and now I got to solve for S. So again, how am I going to get S by itself? I have to divide by the square root of 2. Divide by the square root of 2. So it's nice over on the right side of the equation. Those are going to cancel, so I'm just left with S. Then I'm left with this kind of ugly thing over here. So in math, it's improper, kind of illegal to leave a radical in the denominator. It's kind of like not capitalizing a sentence, the first word of a sentence. So we have to fix it. And how we fix this is you take your fraction times the square root of 2 over the square root of 2. Now how do you multiply fractions? Multiply across. So I'm going to get 6 square roots of 2 over the square root of 2 times the square root of 2 is the square root of 4, which we can simplify to 2. Now can I simplify that anymore? Yes, I sure can. Because how many times does 2 go into 6? 3. So I end up with 3 square roots of 2. So we just found our leg to be 3 square roots of 2. 3 square roots of 2. Now if you don't believe me, check yourself. If I know my hypotenuse is 6 and I think my leg is 3 square roots of 2, what's 3 square roots of 2 times the square root of 2? 3 times the square root of 4, which is 3 times 2, which gives me 6. Works out. We did it right. Way to go. Kudos. Pause the video. Try to do this one on your own. Ready, set, go. You'll thank me later if you actually try this on your own. But at the time, I'm just going to start doing it right now. So again, we are given our hypotenuse is 11. So I know my hypotenuse equals our leg times the square root of 2. Plug in what we know. I know my hypotenuse is 11, and I'm trying to find out what my leg is. So I'm going to divide by the square root of 2, divide by square root of 2. This is nice, those go away. But now I have to fix this mess right there. I have 11 square roots of 2 times the square root of 2 over the square root of 2, which is just a special version of 1 if you didn't know that, but we'll talk about that later. So multiplying across, you get 11 square roots of 2 over the square root of 4, which we know is really 2. Can I reduce 11 over 2? No, so this is my answer. 11 square root of 2 over 2. And our last problem for the 45, 45, 90 triangle is the length of a hypotenuse of a 45, 45, 90 is 10. What is the length of the leg? And also, what is its perimeter? So this is the picture we're dealing with, and it tells us the hypotenuse is 10. So again, we have to work backwards. We know our hypotenuse equals our leg times the square root of 2. Plug in what we know. Our hypotenuse is 10. How am I going to get s by itself? Divide, divide. Dividing. This is nice, those cancel, but remember this is not proper, so we have to fix it. So I'm going to take 10 over the square root of 2 times the square root of 2 over square root of 2. 10 square roots of 2 over now. Square root of 2 times the square root of 2 is square root of 4, which we all know is 2. Simplifying, I'm going to get 5 square roots of 2. So those are my labelings, 5 square root of 2, 5 square root of 2. Now to answer the second part of the question, it says what's the perimeter? So remember that's just adding up all our sides, so I'm going to have 10 plus 5 square roots of 2 plus 5 square roots of 2. Can I add anything together? Sure I can. I'm going to have 10, this stays by itself, but how many square root 2's do I have? I have 5 here and another 5 there for a total of 10 square roots of 2. Okay, so that's our first special right triangle. Hope we're doing okay. Now it's kind of a lot of info, and we're going kind of quick. But now we're going to turn the page and talk about the 30, 60, 90. So this says it's half of an equilateral triangle. So let's just kind of mark what we know about an equilateral triangle. All my angles are 60s, and I know all my sides are congruent. So let's say just for fun, we call this side 2s, this side 2s, and then this side down here is 2s. Now, if a 30, 60, 90 triangle is half an equilateral one, I'm going to cut it in half. There's my right angle. Here's my 60. Now, here's my 30-degree angle. And then, if I'm cutting this side in half, I know that this is S and this is S. So now, let's see if we can figure out the pattern by using the Pythagorean theorem. So we'll call that our height here, x. So now just punching into the Pythagorean theorem, I'm going to have x squared plus s squared, right? X squared plus s squared equals my hypotenuse of 2s squared. Can't really do much on this left-hand side, so I'm just going to rewrite it. But 2s squared, remember, when you have exponents, you take each factor inside the parentheses to that power. So 2 squared is 4, s squared is just s squared. Okay. Now I want to get x squared by itself, so I'm going to subtract s squared over here to the other side. 4s squared minus s squared is 3s squared. And of course, how do you undo something squared is you take the square root. So we find that x equals the square root of 3 times the square root of s squared. But what's the square root of s squared? Hope you're thinking s, because it is. So s square roots of 3. So, guys, we just again proved the shortcut for a 30, 60, 90 triangle. So this time I have two things I want you to bubble in here. First one is your hypotenuse is 2 times your short leg. So here's your hypotenuse right here, and it's 2 times this short leg. Agreed? If this is s, this is 2s. If this was 5, this would be 10. Okay? Now your longer leg, so the leg across from the 60-degree angle, this one right here, is the square root of 3 times your short leg. So again, it's your short leg, whatever this value is, times the square root of 3. So if this was 8, this would be 8 square roots of 3. So again, bubble this, you need this. This is your friend, it's your shortcut, memorize it. We need that. So now let's fill in the blanks right here. Your shorter leg is always across from the 30-degree angle because that's the smallest angle, so it needs to be the shortest side. The longer leg is across from the 60-degree angle. Because obviously in a right triangle, the hypotenuse is always across from the right angle, so the longer leg is across from the 60-degree angle. Okay, so here we go. What is the length of each side? So first let's decide what information did they give us. So they told us this side right here is 10. Now what leg is that? Well, it's across from my 30-degree angle, so it's my short side. Now, how do you find your hypotenuse? Well, look back up here, guys. Your hypotenuse is twice your short leg. So what's twice 10? 20. 2 times 10. Now, how do you find your longer leg? Well, we take our shorter leg times the square root of 3. So 10 square roots of 3. Okay? Again, we're just following the formulas. That's it. Okay, now let's come over here. So again, start by figuring out what information did they give us. Well, this is across from the right angle, so this is the hypotenuse. So if I know the hypotenuse is twice the short leg, how can I find my short leg? I hope you're thinking you're dividing by 2. So I'm going to take 24 divided by 2 and get 12. There's my short leg, and my long leg is the square root of 3 times my short leg, so 12 square roots of 3. Okay, now again, let's decide on 12 what information they give us. Well, they're telling us that our short leg, because it's across from the 30 degrees, is square root of 5. So now let's find our hypotenuse, which is twice that, so 2 times our short leg, which is square root of 5. And now, to find our long leg, we have to take our short leg times the square root of 3. So this is going to be goofy. I'm going to have my short leg, 5, square root of 5, times the square root of 3. So now it's square root of 5 times the square root of 3. Square root of 15. You doing okay, guys? Okay, turn the page. So again, these ones we have to work backwards is definitely going to be the most confusing. So this time, we are given our long leg. It's across from the 60-degree angle. So how can we find our short leg? Remember, our long leg equals our short times the square root of 3. So plug in what we know. So I'm going to have 15 equals my short, which I'm going to call S, times the square root of 3. Now again, how do we get S by itself? Divide by square root of 3, divide by square root of 3. These cancel, and again, we have to make this proper. So let's scoot over here, 15 square roots, jumping ahead. 15 over square root of 3. Now you're going to multiply by the square root of 3 times the square root of 3. Remember, multiply across, so I'm going to have 15 square roots of 3 over the square root of 9. Well, what's the square root of 9? 3. Can I simplify 15 over 3? Sure can. We're going to get 5 square roots of 3. Okay, so we just found x. 5 square roots of 3. Now, how do we find our hypotenuse? Well, we just double it. So if I'm doubling 5 square roots of 3 times 2, I'm going to get 10 square roots of 3. let's try another. So on 14, they give us, again, our long leg equals 5. So let's find our short. So we have 5 equals s square root of 3. To get s by itself, we're going to divide by the square root of 3. Divide by the square root of 3. Again, that's not proper. So we're going to have 5 square roots of 5 over square root of 3 times the square root of 3 over the square root of 3. 5 square roots of 3. Square root of 3 times the square root of 3 is the square root of 9, which is really 3. Can we simplify 5 over 3? No. So we just found our short side is 5 square roots of 3 over 3. Then to get our hypotenuse f, we double it. So 2 times 5 square roots of 3 over 3 is 10 square roots of 3 over 3. And then 15 here. What is the height of an equilateral triangle with sides that are 12 centimeters long? Well, draw a picture, gives you an equilateral triangle. We want to know the height, x, and we know that the sides are 12 centimeters long. 12. So then I know that if this is the height, then this becomes 6. So we're really just looking for the long leg, right, of a 60, 30, 90 triangle. 60, 30. There's our long leg. So to find the long, we take our short, which is 6 times square root of 3. So 6 square roots of 3. And it says to round to the nearest tenth, approximately 10.4 centimeters. Okay, so you have a book assignment. Show your notes to the sub, and then she'll give you your homework. If you are super confused, please come early in the morning tomorrow. I'll be here. If not, tomorrow's day 2, and we'll hopefully fix any issues you're having. Thank you guys for watching. Have a super great day. We'll see you tomorrow.